I decided to go ahead and record today's lesson, and that's on P5 day 2 because we had some people that were gone, and I want you to be able to take a look at what's going on. No, you will know when you go through this that my graphing calculator simulator for the smartboard is a little clunky, so it might take a little while to get through some of the things that would have been faster had we just used the television calculator here. So this one says we're going to solve using the quadratic formula. And what you have to know about the quadratic formula is that it needs to be set equal to 0 in order for you to use the quadratic formula. The other thing you need to know is that the quadratic formula can only be used for quadratics. You have to have your x, your variable, to the power of 2. That needs to be your highest power. That needs to be your degree. So every quadratic equation can be solved using the quadratic formula. And in class I talked about how it's not my favorite. It's not. I don't like the quadratic formula. It's one of those things we teach you a little song. You've got a nice little mnemonic, but you don't have any idea why it works the way that it does until basically you get to calculus. So we're going to use it just because it's a backup plan. Now I noticed here that this is not solved for 0. So 3x squared minus 6x minus 5 equals 0 will give us an a value of 3 and a b value of negative 6 and a c value of negative 5. And then it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you want to do a little bit of the math as you go through, to pick up a little bit of it. So x equals the negative of a negative 6 is 6, plus or minus the square root of negative 6 squared is 36, minus 4 times 3 times negative 5. And that will all be over 2 times 3, which is 6. So x equals 6 plus or minus the square root of, well, that'll be 36 plus, and then we'd have 12 times 5, which would be 60, over 6. Or you could just, punch in everything underneath the radical there, and you wouldn't have to necessarily do the calculations by hand. But x will equal 6 plus or minus the square root of 96 over 6. Now, since the quadratic formula is kind of our fallback, hey, I've totally forgotten how to do any of this, usually we will give these answers in decimals. So quick reminder that we want to go 3 decimal places to thousandths with rounding in here. And I'm trying to keep this to where we can see it. I'd have to move things up a little bit while I am punching this in, because I want you to see that if you do a good job punching in the first of these two solutions, then the second goes much faster. So here's what we need. We're going to need to tell the calculator all of this stuff on the top of this fraction is together. So 6 plus second square root of 96 all together. And, oh my goodness, this is clunky. Parentheses, 6 plus second square root 96 parentheses, and this is one of those things where I have to hit this out before I put my parentheses on. So this is a newer version of a calculator than I have on the TV at school. A little bit different functions. You guys are probably experiencing that too with color calculators. And there we go. So 2.633 to 3 decimal places. And then what I can do is I can hit second, enter, and I can go back and change this to subtraction just by using arrow buttons. And oh, there it went and hit the wrong one. 6 minus, there we go, and enter. So negative 0.633. And those would be the two solutions. So 2.633 and negative 0.633. Now, pretty obviously, we also could have gotten that graphically, because we can graph all of our quadratics. We could go into y equals, and we could put in the 3x squared and that is minus 6x minus 5. Graph that. And then use our cursor, blinky here, on second trace. And this time we're going after the zeros. We want to see where does it cross the x-axis. So we could hit left, right, enter through guess, and it's the exact same answer that we had. It's our negative 0.633, and then second trace number 2 again, and move to the other intersection, but this time we will have to be below the x-axis in order to be left of it, and then we have to be above it to be right of it. And there is our 2.633. So quadratic formula, yes, we want to be able to use it, and it is, like I said, it's a backup plan. You don't remember anything else about quadratics, but you remember that song and the quadratic formula, and by golly, you can use that. But we always have that calculator to back it up too. So let me move this one down. All right, there we go. 2x squared minus 3x minus 1 equals 0. You have to have it equal to 0 to use the quadratic formula. A is 2, b is negative 3, and c is negative 1. And x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals the negative of negative 3, which is 3, plus or minus the square root of negative 3 squared is 9, minus 4 times 2 times negative 1, all over 2 times 2, which is 4. So x equals 3 plus or minus, well, this will actually be 9 plus 8, the square root of 17, over 4. And then again, this would be something we would just punch in. And rather than go through and punch it all in again, you could certainly do that. We get 1.781. And we get negative 0.281. And one of the things we should get used to is being very specific about what's going on. So rather than an equals here, we would want to put a wavy equals, which means approximately equal to. So these are not exact. We know that. We did some rounding, but we should go back and say, hey, this is approximately. And that's because when you get to the calc exam, you want to be very picky, and you want to make sure that every step is done exactly as you want it. And that's going to mean, and again, it's not letting me grab this. There we go. That means that we have to be able to write what we would want to say to them. And that means if we're going to use the language, well, it was approximately this, we need a symbol for that, and we have one. So the big here is be sure you know all 4 algebraic methods for solving quadratic equations, and think about how you decide which method to use. Which ones you like better. Pretty obviously, we'd like to factor if we can. Easiest, fastest way to get some nice integer answers. But not everything is going to be factorable. And sometimes you notice that you have squared terms, but you don't have any to the first terms. In quadratics, that would mean you have x squareds, but you don't have any x's by themselves. So the best thing to do in that situation is get the squareds on one side and solve to take the square root. And then we can always use completing the square, but the one glitch with completing the square is you must have a 1 in front of your squared term. It has to be your leading coefficient in your quadratic. So now, solving equations numerically, like it says, sometimes it's difficult to solve equations algebraically, and an approximate solution is sufficient. And that's when we use table feature on your calculator for this method, or some other methods I'm going to show you in a little bit here. This is actually my least favorite, but it does show you guys how to manipulate your table, which a lot of you have never done before. Agreement about approximate solutions. For applications, round to a value that's reasonable for the context of the problem. For all others, round to 3 decimal places unless directed otherwise. And that's because the AP exam in Calc has you round to 3 decimal places. So in Calc, there's a mandatory minimum of 3 decimal places, but the College Board encourages exactly 3 and only round your final answer. No rounding early. So don't round in any of your beginning steps. You know, keep the math in your calculator and keep working with it as you go through. So what we're going to do with example 6 is we're going to solve using a table, and then I'm going to show you a method we've already talked about in class that does that much quicker. So we have x cubed minus x minus 1, and we go to our calculator and we pop that in. So again, that was x cubed minus x minus 1. And maybe just take a quick peek at it so you can see what it is. Looks like so. So we look at that and we realize, well, the solution's got to be somewhere between 1 and 2. Well, let's take a peek. Let's hit second table. And how we know that it's between 1 and 2 is by looking at the y values. This was a negative y, which meant it was under the x-axis, and now it's a positive 5. That means it's over the x-axis. But here's the thing, I'm supposed to do this 3 decimal places. Well, that's not going to do it. So I'm going to go into second window, which is my table set. And I'm going to tell my table, go ahead and start at 1, but this time let's go by tenths. So I can get a better idea in the table of what my answer should be. And I now notice this is negative, but this is positive. So it's 1.3 something. So I go back into my table and I say, you know what, table, start at 1.3, but let's go by hundredths this time so we can get an accurate read of what's going on there. So second table, 1.3, and then I notice it must be 1.32 something because my y value is a negative 2 hundredths, and then at 1.33 it's 0.02264, which is positive. So 1.32 something, back to the table. 1.32 something, but now we want to go by thousandths. Table. Now we see it has to be 1.324 something. But again, we want to round to 3 decimal places, so we really need to see a fourth. So second table set, 1.324, but we need one more decimal place. We need that 10,000ths place. And you'll notice scientific notation comes up. That's perfectly fine. It's just the calculator saying it doesn't want to store all that for us. So now we come down here and we see 1.3247 is negative. 1.3248 is positive. And if we round to 3 decimal places, that will be 1.325. We don't want to forget to write the answer down as we go through this. So that is definitely the slow way, but we got it. You know, like it says, you keep changing your tables. Notice here, hundreds, thousands, just keep going until we can get to 10,000ths and find that. And we saw that when we went ahead and graphed. You know, we were able to get that point. But much faster would be just to use the graphing calculator to find the zeros. So we graph it, and then we're going to hit second trace and use Blinky to find the zeros. So second trace, number 2, find the zeros. Blinky is almost in position. I'm going to have Blinky just a little below and to the left, and then I will hit my Blinky there, my cursor to the right, and I'll hit enter through guess. And there it is, 1.325, but it didn't take all day. That's the problem with using the table feature. It's just another way to go, but it definitely, to me, it just seems like a big waste of time. So when you get to your homework and it says solve using tables, ignore that. Don't use the tables. Go ahead and use the zero feature. So our extra calculator work here is that we are going to figure out intersections and such. And the first one says we're going to graph the equations 3x squared minus 6x plus 1 and g of x equals 0.23x minus 2.25 and determine the points of intersection. So away we go. Let's get it in here. So that first one was 3x squared, and that is minus 6x. Oops, it didn't take the minus. There we go. And then we have plus 1. And the second one was 0.23x, and that is minus 2.25. So let's see what it looks like. Let's zoom 6 this. If we need to, we can always change the window and make it a little bit bigger. But there's the first graph. Our first one was a quadratic, and the second one was linear. And yeah, they're hitting right there. So that's an intersection. Let's hit second trace, number 5, and tell Blinky, come on down here, Blinky. I'm pretty sure there's an intersection coming down here. So right there. There might even be 2. And we hit enter to guess, and look at what we get. No sign change. Calculations are not detecting a sign change to give an estimated result for the allowed number of iterations. What does that mean? It's trying to tell us they didn't hit each other. But if we look at this graph, we would absolutely be convinced that there's an intersection there. Well, we need a closer look. So let's hit zoom, and I want to teach you about zoom box. So number 1. So here's how zoom box works. We're going to get a cursor, and what we want to do is put that in the upper left-hand corner of what we want to see. And then we're going to use our arrow buttons to go down and to the right, and then we'll hit enter again to form a box. So where you see the arrows here, right here is where we start, and this is where we end. And what the calculator will do for us is it will blow up that region. So I need my little cursor, and I'm going to make my box starting right there. So then I arrow down, and I arrow to the right, in the hopes that I can see this region a little more closely. And I hit enter, and it's going to zoom in on that. So there's my quadratic. There's my line. And you start to see that, hey, maybe those 2 aren't touching. But just to be certain, let's do zoom box one more time. And let's get Blinky to where we would absolutely be sure that these are not going to hit if we make a box right around this intersection region. Because if we are going to say no solution, we better be doggone sure there's no solution. There's our quadratic. And there's our line. And oh my goodness, is it obvious? They do not intersect. So for this first extra calculator problem, what this was about was showing you something we call grapher error. It's not that it graphed it wrong, it's just that the calculator has only so many pixels. It can only get so close. So we have to know the difference. And when we get an error message from our calculator, we have to know what it's trying to tell us. Now the second one, using your calculator to solve this one, and that's going to be using the intersect feature. This is what I need to point about this one. They are saying just between the x values of 1 and 6. So we'll go back into y equals. We'll clear out these 2. And we will start again. And we will do x cubed. And then we had minus 6x squared. And a plus 9x on the left-hand side. And on the right-hand side, we need the square root of x. Oops, I'm used to my older calculator here, so I'll delete that out and pop that out. All right, now I'm going to go back to Zoom 6 for a second. But they're telling me they don't want all of them. They only want the intersections that appear between 1 and 6, including the 1 and the 6. So I'm going to go into my window like they told me to, and I'm going to change my x's from 1 to 6. And then I'll go ahead and use Blinky to figure out where those intersections are. There is another intersection, by the way. It's at 0, 0, but they didn't want that one. They just wanted to know what are the intersections between 1 and 6. So second trace, number 5, and I usually just do the left one first. You wouldn't have to. You could do the right one first if you want to. But you have to make sure that Blinky knows, hey, go all the way over here and find where that one intersects that one. So you enter 3 times. And we get 2.177. I'm going to write that down. And let's see, the y value with that 2.177 was 1.475 because this is an intersection problem. This is not a solution problem. And then we'll go after the other one, second trace, number 5. And let's get Blinky over here to the other intersection. And enter, enter, enter. So that one is 3.720, 1.929. 3.720, 1.929. And now you've seen what you need to see to work through the rest of this. And like I said, it wouldn't be a bad idea to go ahead and give the rest of this page a try and realize that yes, we see graphing error from time to time as you go through those. But what you need to do is day 2, and I had told everybody finish this completing the square worksheet by Monday. I'll collect that up on Monday. So do a little bit today, a little bit tomorrow, a little bit the next day. But make sure that you're doing the day 2 assignment here, that you're working with the quadratic formula. Solve using tables, like I said. Don't even do that. Use the intersect feature, or if we're solving, you could go ahead and use the 0 feature. Anything that's easier for that solving. And then just choose what you want to do for the rest of those. And again, try and do a little bit on that completing the square worksheet.